Good morning, Emily and Priya. So, both of you are going to present the redox reactions in particularly D block elements. Okay, redox reactions using half cell method. This is also called ion electron method. Okay, see, using acidified K2Cr2O7, and this can be in the ionic form also. How can you write down the ionic form of K2Cr2O7? Cr2O7 2 minus. Okay, write down Cr2O7 at the top. Cr2O7 2 minus. So what do you call it? Dichromate anion. Okay, so likewise, so this is one of the very good oxidizing agents. Okay, then can you get me another oxidizing agent from D block? MnO4 minus. That is potassium permanganate. Okay, potassium permanganate, MnO4 minus, right? So using these two types of oxidizing agent, and that is duly acidified. How to represent the acidification? Just put H plus, right? Okay. Now you are going to use these two oxidizing agents differently. Okay. For oxidizing thiosulfate to dash. How the thiosulfate is oxidized? Sulfate. What is the formula of thiosulfate anion? S2O3 2 minus. Write down. So plus S2O3 2 minus. Right. So this is called thiosulfate anion. Okay, so what will happen to that MnO4 minus? Mn2 plus, that's good. And what about this one? Cr3 plus. And what about this thiosulfate? How it becomes? It is oxidized to sulfate, SO4 2 minus. Plus you can put dot dot dot. We can balance it and find out, right? Okay. Now we have here thiosulfate that is oxidized to sulfate anion, that is SO4 2 minus. In this case you are using Cr2O7 2 minus. So can you proceed by adopting the half cell method? Okay, yes. So first you can explain, meanwhile you can do your thing. Okay, so first you explain, then after presentation you can proceed, right? So first we are taking the oxidizing movement MnO4 minus. See, actually, Priya on the left side is using KMnO4 as the oxidizing agent, that is MnO4 minus. And Emily is doing Cr2O7 2 minus as the oxidizing agent, right? Right, proceed. So MnO4 minus will be oxidized to Mn2 plus. So to balance the oxygen, we need to add H2O, water molecule, on the deficient side. So MnO4 minus to form Mn2 plus 4H2O. On the deficient side, we are adding water. So we need to balance hydrogen. We need to add hydrogen on the deficient side. Hydrogen deficient side. So 4 2s are 8H plus to form Mn2 plus 4H2O. So now we need to balance the charges. To balance this charge, we need to add 5 electrons. So we completed the half cell reaction here. So should I write? Then we are taking the reducing part, reducing agent. So to balance the oxygen here oxygen is deficient, so we are adding 5 water molecules. So first we need to balance the sulfur here. So we need to add 2 over here. So the oxygen will become 8. So 5 water plus 3. So 5 plus 3 is 8. So 8 oxygen.
We are adding 10 H plus because we are adding 5 twos are 10 hydrogen here. So on this side also we need to add 10 hydrogen. Then we need to balance the electrons. We are adding 10 electrons here because of. So should I do that algebraic method also? How this
Yeah, you had to do. You can show
like
how the
when
electrons are added. You can put it here at the bottom and you can erase it later. Otherwise, you erase that part and show that how to do that.
so the charge of thiosulfate is -2, which is equal to here there is no charge. So here it is -4 plus 10. 10 into 1, 10 electrons, so 10 plus x. We are keeping SO4 minus as x. So we will get x is equal to 10. So if we do this part, -2 equals to 6 plus x, where x is equal to 8 electrons. 8, we'll get 8. So we need to add 8 electrons on the depletion side. So we need to add 8 electrons on this side. So plus 8 electrons. So to balance the electrons on the this side, we need to multiply this equation by 8 into 8. So we need to balance this by multiplying 5. So we'll write the reaction here. 8 MnO4 minus plus 16H plus 40 electrons, 48 to form 8 Ma2 plus 32 H2. So this side we need to multiply this entire equation by 5. So 5 is 5 S2O3 2 minus plus 25 H2O to form 10 SO4 minus 2 minus plus 50 H plus 40 electrons. So we can cancel this 40 electrons and this side 40 electrons. So we need to combine this both these reactions. We'll get 8 MnO4 minus plus here in this side 16H plus over there 50H plus. So we need to subtract 50 minus 16. We need to write it on the other side. So let it be here. 8 MnO4 minus plus 5S2O3 2 minus. So here 25 H2O is there and here 32. So 32 is more, so we need to add water molecule on that side to form to form 8 Mn2 plus. So here for 40 minus 16 we'll be getting 14H plus 10H2 minus plus 7H2. So over here 8 8 are 64, it will become 64H plus So if we subtract 54 minus 50, we need to write this 14H plus on this side. So left plus 14H plus 5 S2O3 2 minus to form 8 Mn2 plus 10 SO4 2 minus plus water. 32 minus 25 will be getting 7 molecules of water. 7 H2. So we need to check it by using ERP method. So should I do ERP also?
Yeah, you can do later. Okay.
Yes.
Now, is there any question? If there is any question, you can ask me. Okay, let me ask you some questions.
Yes.
What is the oxidizing agent in this reaction?
MnO4.
MnO4 minus, and that is duly acidified. Okay, so in this case, you can use sulfuric acid as the acid here. Okay, suitably. And but we have shown this as H plus only. Okay, this is totally an ionic reaction. This type of balancing of a chemical equation will be very, very helpful for you in electrochemical reaction also. Okay, and what is the other name of this method? One is a half cell method, another method ion electron method. Now, what are the major steps you are supposed to follow in ion electron method? Can you explain?
Yes, so first we need to split it as oxidizing agent part here and the
Reducing
part
agent.
here.
Okay.
So this is the first important. Then we need to adjust water molecule by adding two.
Now, first of all, you have to balance the cation.
First we need to balance.
So it is already balanced.
So to balance the oxygen, we are adding water molecule on the deficient side.
Oxygen deficient side. So oxygen should be balanced only by adding water. Then only you have to take up the hydrogen. So here the very important thing is you must add water molecule only for adjusting the or balancing the oxygen atom. Then proceed to hydrogen.
So 8 hydrogen.
How you balance the hydrogen atoms?
By adding H plus.
Very good. So these two steps are very, very important.
So then again like that.
No. You can proceed with that. 8H plus here. You are adjusting.
8H plus. So then we need to balance the electrons. We are adding 5
see,
electrons.
a balancing of electron is a tricky affair, is it not? So that is why we put the algebraic method. So can you show the algebraic method here, so that you can find out the number of electrons to be added? You can write at the bottom. Put it a box.
So for this K1O4, the charge is -1 plus 8H plus, which is equal to plus 2 plus X. So
no, X should be added on the left side or right side?
Left side.
Right side, left side. You have added on the right side. Because X is the number of electrons. Do you understand? So the X represents the number of electrons to be added. In this case, on the left side. Why it is left side? Because reduction. Electronation is reduction. Reduction. Okay.
Yes. So therefore the X value is 5. So we are adding 5 electrons.
5 electron. Okay. Good.
So 5 electrons.
So you must put -5. That is 7 minus 2 minus 7 minus 5. Electron is -1. So 5 into -1 means -5. So 5 electron you have added. Okay. Right. And similarly, here you have already done it. Okay. Very good.
By combining both, we need to multiply this equation by 5.
Okay.
And then this equation by 8. Then we need to cancel the electrons. 44. Then we will get this.
Okay. So you do one thing, that is for at least for first stage. Let us prove that balanced equation by ERP table. Okay. And maintain the last one. Remaining can be erased.
Yes.
Right. Emily, what about your equation?
Sir, it is Cr2O72 minus.
What do you call this Cr2O72 minus?
Sir, it is dichromate.
Dichromate anion. Okay.
First, we should divide it into the half cell method.
What is the reducing agent here?
Sir, yes, 2O3 2 minus.
2 minus. That becomes
SO4 2 minus.
Actually, reducing agent undergoes oxidation. So thiosulfate becomes sulfate. Okay. So using Cr2O7, you are reducing S2O3 to SO4 2 minus. So that is our purpose. Right. Proceed.
Cr2O7 2 minus gives 2 Cr 3 plus 7 H2O.
Priya, wait, Priya. Let us do it live. Okay.
To balance the oxygen, we need to add water, sir. Next step, we should balance the hydrogen by adding H plus. So 7 to 14 H plus gives 2 Cr plus 7 H2O. Now to balance the electrons, I have done the same method that Priya have done. Adding 6 electrons and
so you have to be very careful while adding electron on the left side, put the X on the left side. While adding electron on the right side, put the X on the right side. So that is the strategy you have to maintain. Right.
I will just compare and see this one also. S2O3 2 minus gives 2 SO4 2 minus. To balance the oxygen, here 4 oxygen is there, here 3 oxygen is there. So we need to add a water molecule on the left side here. So 5 oxygens plus here is 2, so that is balanced. 2 4s are 8 oxygens are balanced. Next, adding the hydrogen on right hand side, 10 hydrogen, and the electrons 8. By using the same method, I attained that 8. And to balance these two reactions, that to give the electrons the same amount of electrons on the both sides, I have done.
So our objective is to eliminate that electron in the combined reaction.
So I have done.
So that you have to accordingly balance it and take the LCM of these two.
Here I have done it with 8 and there's 6. So by that we can attain the equal amount of electrons we need to, which are needed to be cancelled. By the next step, I have cancelled all the electrons and the hydrogens and water molecules. By that we attain 8 Cr2O7 plus 52H plus 6 S2O3 2 minus gives 16 Cr3 plus 26 H2O plus 12 SO4 2 minus.
You can do one thing. Since all are divisible by 2, you can divide entire equation by 2. Okay. So show that. Divide by 2. 4 Cr2O7 2 minus. Okay. Right. After that, you have to prove that by ERP method. Okay. Right. Now you can do the KMNO4
So
reaction.
first we need to eliminate, list out the.
Shall I rub this or?
8 times.
So shall I rub this or?
Yeah, you can maintain.
So first we need to list out all the elements which is in the reaction. So we need to see in the reactant part how many manganese are there. So 8 manganese on the reactant side. Then on the product side 8 manganese. Then coming to sulfur, there are 10 sulfur in the reactant side. In the product also 10 sulfur.
Good.
So for hydrogen we need there are 14 hydrogen in the reactant part. Then 7 2s are 14 in the product part. For coming to hydrogen, coming to oxygen, 8 4s are 32 minus 32 plus 4 plus 15. 5 3s are 15 oxygen. Coming to the product part, 40 plus 7 oxygen in the product part. So next we need to come to the charges. Minus 8 plus 14 plus 10 minus 10. Minus 10 under reactant part. Then coming to the product part, we are having 16 plus minus 20. That's it, minus 20. So if we check it, there are equal number of manganese in the reactant product. Here also same. Here also same. Here if we minus 32 minus 50. So here it will be,
Check that. 5 3s are 15, is it not?
yes, sir.
And then there 8 4s are 32. Here 40.
Minus 32 plus 14. Oxygen part
Oxygen per how
40
much? 40 plus
plus 7.
7. 7H2.
So here we are going
32 plus 15, how much? Why you put minus? That is not charge, no? You are counting only oxygen. So 32 plus 15, 47.
47.
Ah.
So here also 47, so both are balanced. So here if you
See, when you calculate the charges, you have to take the minus plus, otherwise leave it. Hmm.
so if we calculate it for minus 80
Plus 14.
plus 14, we will get minus 4.
Hmm.
So here also we get minus 4.
So
Therefore,
everything
the
is
entire
balanced. Very
is
good.
balanced.
So this is perfectly balanced. Okay, good, very good. Right. You can come. You can proceed, Emily. Hmm. Like what Priya did, you should also try to verify by ERP table finally. Okay.
So see first CR, that is in the reactant side it is 4,
Hmm.
and in the product side it is 8, sir. 8. Here also 8.
Hmm.
And next is next is hydrogen. Here I have 26. There I have 26. 13 twos are 26. And here S I have 6. Here also I have 6. And oxygen, here I have 3. 3, 3, 9. 9 plus 24. Here also I have 13 plus 28. So it is
What happened?
sorry,
Move that.
this reaction.
Move that side. What is that? See, oxygen, you are counting oxygen. 4 into 7, how much? 28.
Yeah.
Then 3 into 3, 9. Okay, finished. And what about this? 13
13.
and 24.
Sir, then equal.
You check.
Okay.
Charge finally.
Yeah, charge. Here I have 2 minus 4. So 4 minus 8 plus 26 and minus 6. Here I have 24 plus minus 12. 6 twos are 12. Sir, for me here it is coming 24. But it is not
26. Minus 8 minus 6, how much? Minus 14. Right? Minus 14 plus 26, how much? First add minus 10.
12. Correct? or
Sir,
not? 12 only. It's balanced.
Check that oxygen.
it is 37, sir.
This side.
37.
Put take note.
6, 6, 26, 8.
You just explain from this side and explain. Explain. Explain.
Okay. So CR, sir, first element.
Hmm.
For that, 4 2s are 8 in the reactant side. And CR in the product side, it is 8. So it is balanced.
Hmm.
Next, H plus. Here it is 26 and here 13 2s are 26. It is balanced.
Hmm.
And yes, here 3 2s are 6 and here it is 6. It is balanced.
Hmm.
And oxygen, here we have 3 oxygens. Into 3, it is 9. And the next one is 7 into 4, it is 28. And in the product side, we have 13 oxygens, so 13 oxygen plus 24 oxygen, 4, 6 are 24. And
Totally how many oxygen? You have to write down that one.
37, sir.
So there also 37. Right. And then
And
net
on the
charge.
net charge, we have minus 8 because minus 2 into 4 minus 8
Hmm.
plus 26 minus 6. 3 2s are 6. And in the product side, we have 8 3s are 24 and minus 6 2s are 12. We have calculated.
Plus
here.
12 on both sides, right? Okay. So it is well balanced. Good. Yeah, the next candidate can come. Yourself. Gangesh, come.
Sir, completed.
Explain.
So we have permanganate to form manganese 2 plus ion, cation. So now we have to balance the oxygen by adding water molecule.
No. What you are going to do? Using manganate, permanganate, what are you going to do? First, you should write down at the top,
Like this.
Using KMnO4, what are you going to do? Using potassium permanganate anion, you are going to oxidize nitrite as nitrate. First, write down that. That is the incomplete reaction. So similarly, Gangesh, what are you going to do? Using Cr2O72 minus acidified, you are going to oxidize nitrite to nitrate, right now. So Carinia is using potassium permanganate as the oxidizing agent. Gangesh is using Cr2O7 2 minus as oxidizing agent. Right, proceed. Right. Right, proceed.
So we have permanganate to form manganese 2 plus ion. So we have to balance oxygen by adding water molecule on oxygen deficient side. So here 4H2O. Now we have to add hydrogen in hydrogen deficient side. So MnO4 minus plus 8H plus 4 2s are 8. So to form Mn2 plus 4H2O. By algebraic method, we will get 5 charge. So
No, you explain first. How you get -1?
minus 1 plus 8 is equal to plus 2 plus x.
Why you put X on the other side?
Which one, sir?
Priya, go and correct it.
X should come this side. 4 plus x.
See, it is electronation. Oxidizing agent undergoes reduction. Reduction means electronation. So we represent the electron as X, right?
The electron will come this way.
The electron on the left. So for oxidation, this is the reduction. Oxidizing agent undergoes reduction. So we take X as the number of electrons.
So
Explain once again. Explain.
here we have minus 1
Hmm.
plus 8 plus charge at 8.
We want to find out the number of electrons to be
Yeah.
added. So I have put here X on the left side, right?
Is equal to 2.
That is equal to 2. Why? Because Mn2 plus is 2.
Yes. If we solve, we'll get 5.
No, you cannot do it straight away. See, the people who are watching should follow seriously. 7 plus X is equal to 2.
So x is equal to minus 7.
Minus, How minus 7? 2
2
minus, you have to put 7 on the other side. No? 2 minus 7, how much?
minus 5.
Minus 5. Write down minus 5. Okay. So this minus 5 represents what? 5 electron.
Electron.
5 electron. Electron is minus 1. That is why you have taken 5e. Round that 5e. Do you understand now the meaning of x? Right? Okay. Then proceed.
So finally we will be getting MnO4 minus plus 8H plus 5 electron to form Mn2 plus 4H2. Now we have to see reducing agent, which is nitrite to nitrate.
Round it, otherwise you will get confused.
Nitrite to nitrate. So we have to add oxygen in oxygen deficient side. So we have NO2 minus plus H2O to form NO3 minus. Now we have to add hydrogen deficient on hydrogen deficient side. So NO2 minus plus H2O to form NO3 minus plus 2H plus. So to find the charge, we by algebraic method here minus 1 plus 1 is equal to minus 1 plus 2 plus x. X is nothing but we are finding the charge. So
That is number of electrons.
Number of electrons.
So work out seriously. Listen, NO2 is minus, and is there any plus 1 there? Why you put plus 1? Okay, right, minus 1, and then this side?
Minus 1 plus 2.
Minus 1 plus 2.
So minus 1 plus 1 minus 2 is equal to
Yes.
x. X is equal to minus 2. So 2 electrons. So finally we'll be getting NO2 minus plus H2O to form NO3 minus plus 2E plus 2H plus. Now we have to see compare both the reactions that the charge should be equal. So we are multiplying this first equation by 2 and second equation by 5.
So on the reduction side, you have got 5 electrons only. It is a 5 electron transfer. Okay, whereas the oxidation of reducing agent is 2 electron transfer. So it should be exchanged. So you must get equal number of electrons. So take the LCM between 2 and 5. So it is 10. So multiply by 2 and this one by 5. Okay, right, proceed.
After multiplying, we'll be getting 2 MnO4 minus plus 16H plus 10 electron to form 2 Mn2 plus 8H2O. Same as for second equation, 5 NO2 minus plus 5 H2O to form 5 NO3 minus plus 10 electron plus 10 H plus. Now we have to cancel the like terms. Here we have 10 H plus and 16 H plus. We can cancel and we'll be getting 6 H plus. And the electron will be cancelled since it is equal. And then here water also will be get cancelled by 3 H2O.
Why? Because they are on the opposite side.
Opposite sides. So finally we'll be obtained with 2 MnO4 minus plus 5 NO2 plus 6 H plus to form 2 Mn2 plus 5 NO3 minus plus 3 H.
Okay, so now you prove by ERP. Right. Now you can explain. Hello? Proceed.
1 second, sir.
No. Let me check simultaneously. Proceed.
So, sir, we are working on Cr2O72 minus plus 2H plus 2 plus NO2 minus to form Cr2 3 plus NO3
Cr3 plus NO3 minus. And what is the left side? Which is, you are taking ulta. Erase totally. Take the oxidizing agent on the left side. Which is the oxidizing agent?
Cr2.
Proceed. Yeah, do the ERP. You can speak while writing. Cr2O7 2 minus becomes a Cr3 plus.
Cr3.
Then Cr2O7 2 minus.
This by 2 because
There are 2 chromium.
So that's
Then what are you supposed to do? Why you take H plus immediately?
First, we are adding water molecules to balance it.
First,
Balance
oxygen should be given importance. Do you understand? Right, proceed.
And first, we are balancing the oxygen. So, we are adding 7H2O
Hmm.
to balance it. And we are adding 14H plus.
No, you should not write like this. Show this as steps. See, when I teach you something, you strictly follow my instruction. Okay. Hmm.
2Cr3 plus. Second.
2Cr3 plus. And then we are adding 14H plus here. So 14H plus.
First, you write Cr2O72 minus.
So Cr2O7 2 minus plus 14H plus to form 2Cr3 plus 7H2O. And then we are doing algebraic method to find the
Charge.
And then first we are doing minus 2 for Cr2O7 2 minus plus 14 equal to 6 plus x.
Why X that side?
Because we are
X
taking
should be added on the left side, is
Yes,
it not? This is electronation, is it not?
Electron
It is oxidizing agent. Where should be electron added?
in left side.
Left.
Right side.
Right side or left side?
Right side.
On the left side. It is electronation. Add X on the left side. Erase it. Y plus minus. Right.
X minus 12.
How minus 12? Minus 12, 2 plus.
12.
Ah.
Plus 12.
Hmm.
So x is equal to minus 6.
It means
It means we are
6
doing
electrons
that
should be added
in left side.
left side. Proceed.
So Cr2O7 2 minus plus 14H plus 6E to form 2Cr3 plus 7H2O.
Right. So this is the balanced
This is the
half
balanced
cell.
oxidation. And then
First put the line.
Except the last line. Except the last line.
So this is declare this as the balanced half cell reaction. What is that reaction?
Cr2
Half cell oxidation or reduction?
oxidation.
Is it oxidation?
Reduction.
Is it reduction?
Yes.
Why it is reduction?
Because in oxidation reaction, the O plus will increase. Oxygen.
And
will
you
increase.
told it is a reduction. Why it is a reduction?
Because there's no O on
6 electrons are added. No addition of electron. Is it not? Write down. Addition of electron is reduction. I have given a acronym. What do you call that? Mnemonic for this. What is that? Write down. Leo Gar. Leo. Capital. All capital. Leoger. What is Leo? Leo. Loss of electron oxidation. What is that?
loss of electron oxidation.
Gain of electron
Gain of electron reduction.
reduction. Do you understand now? What is oxidation?
Oxidation means losing of electron.
Loss of electron is oxidation. What is gain of electron?
Reduction.
Reduction. Don't forget. So whether it is a Gar or Leo, this left part.
It is the
Gain of
gain
electron.
of electron.
Why you say Leo? Write down. So that is, and what is this oxidizing agent or reducing agent?
Oxidation.
Write down. OA. See, you are not following. That is the biggest mistake you are doing. Next, proceed. Reducing agent or A.
Then
Round it.
NO2 minus to form NO3 minus first we are adding oxygen on left side. Plus,
Speak aloud.
first we are adding
What is NO2 minus?
NO2 minus is nitrite.
Nitrite anion.
Nitrate anion. And then we are adding H2 on left side.
Why?
To balance the oxygen. Because in deficiency. So NO3 minus. So now we are adding.
Just a minute. You can proceed. You explain.
So E is nothing but elements. Elements, reactant and product. In element we have Mn and
Nitrogen.
nitrogen, hydrogen, oxygen and charge. If we see Mn, we have 2 Mn here in product reactant side and 2 Mn in product side. So next is nitrogen. We have 5 nitrogen in reactant side and 5 nitrogen in product side. Then if you see hydrogen, we have 6 H plus. This side also we have 6. 3 2s are 6. Then in oxygen, we have 8 plus 10, which is 4 2s are 8. 4 2s are 8 plus 10. And then here 3 5s are 15 plus 3. 3 oxygen, so 18. Both are balanced. And then if we see charge, -2, -5 and 6H plus 6. So -1. In product side, we have 4, -5, which is -1.
4
It's balanced.
minus 5. Right. Very good. Right. Next. Have you finished? Yeah, you explain. From that, from nitrite, NO2 minus.
So from nitrite anion to nitrate anion. So first we are adding H2 for balancing oxygen deficient side. In oxygen deficient side. And then we are adding hydrogen in hydrogen deficient side. So, and then we are adding
H plus, you are adding H plus.
on a right side. And then we are doing.
We are not sure the algebraic technique of how you are able to get that charge of electron.
Yes, sir, I'll do so. -1 equal to -1 plus 2 equal to plus X. I will do it here, sir. -1 equal to -1 plus 2 plus X. And then we are -1 equal to -1 plus X and X is equal to minus.
Why?
Oh, sir, plus 1, sir. The plus 1 will come because plus 2. And then it will become like -2. So in this -2 will be adding here, sir.
Right.
So and then we are multiplying 3 because so we need to take out the cancel out the C. So we are multiplying by 3 here, sir. And then this is the multiplied equation, sir. 3NO2 minus plus 3H2O to form 3NO3 minus plus 6H plus
Good.
6C.
Right. Then
And then we are cancelling 6C and 6C.
write down the combined reaction. Erase all these things. Sushmita, what are you going to do? Explain.
I have taken
Permanganate. What is that?
permanganate.
Permanganate as the permanganate anion. Acidified permanganate anion as the
Agent.
what agent?
Oxidizing agent. Oxidizing agent.
Which is oxidized here? Which is oxidized here? MnO. That is oxidizing agent. Which is oxidized here? Sulfite. What is that?
Sulfite.
SO3 2 minus. What is that?
Sulfite.
Sulfite. Sulfite is oxidized to
SO4 2 minus.
What is that? Sulfate. Okay, you should name it. Sulfite, SO3 2 minus, sulfate, SO4.
2 minus.
So sulfite is oxidized to sulfate, right? Right, proceed. And which is the oxidizing agent? MnO4. Which is the reducing agent?
SO3 2 minus.
Write down SO3 2.
So this is
Put
the combined
RA. Right, you can proceed. That is the combined
combined
equation.
equation of the-
Read this.
So Cr2O7 2 minus plus 3NO2 minus plus 8H plus to form 3NO3 minus plus 2Cr3 plus 4H2O.
Right. Verify this by ERP. Yes, yes.
Except the last equation.
Okay.
You can explain while writing. What is that oxidizing? No, you can do.
So this is permanganate to magnet. So MnO4 minus Mn2 plus, we are oxygen deficient side, we are adding 4H water, water molecule. So 4H2O. So here 14 H2O said.
How 14? 4 into 2, 14.
14. 8 2s and 8.
Write down.
So to balance hydrogen here, so I have taken 4 into 8, so 8H plus. We don't know the electron, how much electron needed to be added. So by algebraic method,
Put X. Put X on the left side. You are going to add electron on the left side.
plus 7.
No, you proceed. Don't follow anybody. So it means, explain that.
Right.
Explain.
So here the charge is -1, so -1 plus 8 plus X. We don't know how much electron needed to be added, so X is equal to 2. So 7 plus X is equal to 2. So X is equal to 2 minus 7, which is 5 electrons needed to be added in the left side.
So -5 means a 5 electron, right? So 5 electron is added on the left side.
Left side.
So that is the balanced one, right? Proceed with that.
So yeah.
Ah. Explain.
So first we are taking elements in this reaction. So Cr,
Louder.
Cr and N, H, O and ions. So first in reactant side Cr is 2. So there are two because Cr 2. And then in
2
product,
chromium. Say 2
chromium.
chromium. On the other
And
side
in
also 2
another-
chromium.
Another side
So
there are two
balanced,
chromium,
right.
So it is balanced.
Hmm.
So in nitrogen, there are three
Nitrogen.
nitrogen in reactant side, and in product side also there are 3 reactants.
Right.
And in H, in
Hydrogen.
hydrogen, there are 8 H plus.
Hmm.
And here also 8 H plus, it also balanced in
Hmm.
product.
Where? You have to show. Where from you got this 8? 4 into 2 where? From water molecule. You have to
From
show.
water molecules. You are getting
Hmm.
4 into 2 from water
Right.
molecules, sir.
From water molecule. Hmm.
And O is coming from seven O is coming from Cr2O7
Hmm.
and 6 is coming from NO2.
Hmm.
And here in product side, it 9 is coming from NO3
Hmm.
and then this 4 is coming from H2 water molecule.
Water
from
molecule. Hmm.
And then we
So
are
7 plus 6, how much?
Seven.
13.
7 plus 6 is 13 and 9 plus 4 is also 13.
So that is
it
also,
balanced.
so oxygen. So all the elements are balanced.
All elements
Now
are
you have to check the charges, not
Charges.
ions, charges.
Charges. So here we are taking first -2, -3 because 3 should be multiplied here,
Hmm.
and -3 plus 8. So it coming like 3 in reactant side, total charge. Here also -3 plus 6 is coming from here, so it's also balanced.
Right, very good. Guru, can you do? Who is the other set?
So
Your
I should
set.
write.
Ah, yeah, come. Priya,
Sir,
you can erase it.
Sir, I should write.
You can erase it, come.
So he should write.
The next one, huh?
Yes, sir.
Ah,
For
okay.
CR2.
Right, proceed. So you are going to use the K2Cr2O7 for oxidizing sulfite to sulfate. Sushmita, can you explain the reducing agent part?
So here I've taken sulfide to sulfate. So to balance the oxygen difference side, I've added water. So here to balance hydrogen, I have added 2H plus. So we don't know how much electron to be added in the right side. So -2 equal to -2 plus 2 plus x. So -2 and +2 get cancelled. So x is equal to -2. So we added in the right side. So now we want to balance both the equations. Now we want to multiply this by 5 and this by 2.
Very good, proceed. Present the subject while you write on the board yourself.
So we are taking oxidizing agent as Cr2O7 minus
Hmm.
to form Cr2 plus, and in reducing agent we are taking SO3 minus to form SO4 minus. So this is oxidizing agent and this is the reducing agent.
Very good.
So now we are going to balance by adding H2O. First we are going to balance O by adding.
Is it correct? Or you are adjusting O immediately? Is chromium all right?
Okay, first we need to add 2 moles of.
Then
So first we have to add 2 moles of chromium
hmm.
because there are Cr2.
Hmm.
So first Cr2O7 2 minus plus 2 minus to form 2 Cr3 plus and then we are adding 7H2O and then we are and then we need to add a hydrogen deficiency right in the Cr2O7 2 minus plus 14H plus to form 2 Cr3 plus 7H2O and then by doing algebraic method we need to find the charge. So -2 plus 14 is equal to
Plus X.
Plus X. Plus X.
Why you put plus on the website? Hmm.
Plus X. And then doing 3 2 6 and then so X plus 12 equal to 6 and X is equal to -6. So that's why we are adding Cr2 charge in 6 here.
6 electrons.
6 electrons in left hand side. So Cr2 goes.
What is your combination? Tell me.
So both the equations I have written here and
So you are combined this and eliminating 10 electrons. Finally,
10 electrons.
you are able to get the combined reaction. Okay, good. Now you had to prove by ERP.
Yeah.
Proceed.
Sorry.
Ah.
Take note of the final.
How will you verify if you erase everything?
SO3 2 minus
Rewrite.
plus H2O form SO2 2 minus. And then so now we are adding by using algebraic method, we are using
Emily and Priya. Emily, what you are going to do is you draw a sketch note. Okay, some concept map for K2Cr2O7 with the different combinations. You put K2Cr2O7, the general equation, balanced equation, and you can write down all the oxidation reactions. Okay, so you can do M1O4. Can you draw this and show it to me? Use this. So you have to write down for
So we need to do it for potassium permanganate or only for permanganate?
permanganate anion and dichromate anion.
For anion.
So you are doing for dichromate permanganate. She is doing for
Dichromate.
yes. Write the balanced half cell reaction of Cr2O7 2 minus, balanced half cell reaction of M1O4 minus, right? Balanced reaction, the final balanced half cell reaction. So he is writing, Cr2O7 2 minus plus 8H plus 6E like that, 14H plus HC plus 2Cr3 plus 7H2. No, completed half cell reaction. Completed half cell reaction of that one. And for the other one, simply put sulfate to sulfate. Full, you put it at the center and like a clock diagram you
First
can
you
do.
do a rough diagram.
No. Put at the center the half cell reaction. Okay. And how many reactions are there? 9. Write all possible 9 reactions. 9 oxidation reactions.
so first in
Ah.
we are going to find we are going to balance in reducing agent, sir. SO3 2 minus to form SO4 2 minus. So first we are adding water molecule in a oxygen deficient side. So which means we are adding H2O in left side, sir. And then we are adding hydrogen in hydrogen deficient side, which is we are adding in right side, sir. And then by doing algebraic method, we are finding the charge of and we are putting in this lesson right side, sir. So so we need to cancel out the charge. We are multiplying 3 in reducing agent, sir. So the final equation is 3 SO3 2 minus plus 3 H2O to form 3SO4 2 minus
Hmm.
plus 6H plus 6C minus.
Hmm.
So by combining, we are getting one equation that this equation,
Hmm.
Cr2O7 2 minus plus 3SO4 SO3 2 minus plus 6H plus
8
8H
H
plus
plus. Hmm.
to form 2Cr3 plus
Hmm.
plus 3SO4
SO4 2
2
minus.
minus.
So like this. And 9
No,
of
at the center, the final completed, you put a big thing, round mark,
only this.
only the last equation only. That is the completed half cell reaction.
So 3SO4 2 minus 3SO4 2 minus plus 5H2O. So
Right, good, very
now
good.
we are going to set up this.
Yeah, you can erase. Okay, it's over. Thank you. You can erase everything. Erase, erase.
Take it.
You can erase that side. Okay. See, that is, you are taking Cr2O7 here. Okay.
See
On that side came, this is Cr2O7. Cr2O7, O7, 2 minus, okay, plus H plus D. Okay, so this is the balanced one. You have to balance it. And take the balanced option. I got already. Okay, how many equations are there? For
9.
example, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what about this nitrite NO3? NO2 minus becomes
9, 3.
NO3. So this is enough. Okay. So likewise you have to show. And what about this SO3 2 minus becomes SO4
Okay.
2 minus like this. Okay. 1, 2. So like a mapping.
In
You
board.
understand?
In board.
Board is
We have one equation. Iodine.
you write all. I just to give the template.
Yes.
You have got 9 reactions, is it not? You write everything.
Sir, but you gave us one equations. We don't.
No. You can do later. First, you do this one. So, Emily and Priya, they are summarizing the entire redox reactions associated with potassium permanganate and the potassium dichromate. So, this sketch note or mind map or concept map will be very useful for you to follow entirely the redox reactions available in your book as per your CBSE syllabus. That is, you got all, I have included every equation, all equations here. That comes under D block elements, right? No, balance it. Balanced equation, balanced half cell. Use the balanced half cell reaction. So this is the overall summary. You can also do it. Karanya, do it. No, don't put dot dot. That is a completed one, is it not? It is a perfectly balanced equation so that you can remember. Okay, memorize it. S2O3 2 minus. Thiosulfate. Use cloth properly. Priya, use duster. Put all these oxidation reactions in a small box so that it will be nice to look at it. Yeah, can you explain now? Use chalk paste.
So
Start from the middle. Explain.
this is the balanced reaction of
Louder, please. Louder.
this is the balanced reaction of dichromate anion.
And this side and explain.
We have 9 reagents. The first one is
No, explain that the first reaction, the center one, oxidation. That is the reduction of oxidizing agent. What is that oxidizing agent? Cr2O7 2 minus. That is potassium dichromate. It is the dichromate anion of that salt. Okay. Then 14. Write down 14 properly. 14H plus.
14H plus 6 electrons gives 2Cr3 plus 7H2
So this is the balanced half cell reaction of
dichromate anion.
anion. Okay.
From the
So
salt K2.
and that is the reduction
reduction.
of an oxidation. This is standard. Okay, this is standard. Okay, then
Since this is the oxidizing agent, these all are the reducing agent.
agents. Okay,
These all undergo oxidation and
Very
this
good.
particular equation undergo reduction.
reduction. Okay,
The first one is I minus to I2. That is iodine to iodine.
iodide to iodine.
Iodide to iodine.
Iodine.
The next one is Fe2 plus to Fe3 plus.
What do you
that
call
is
it? Ferrous to
ferrous to
ferric.
ferric.
So ferrous ion is oxidized to ferric ion. Okay, right. Then
Next is Sn2 plus.
what is that Sn2 plus? Stannous. Stannous becomes
Stannic.
stannic. Okay, then
NO2 minus to NO3 minus. That is
Okay.
nitrite to nitrate.
Okay. Okay.
Next one is S2O3 2 minus to SO4 2 minus. That is thiosulfide to sulfide.
Okay. Then.
C2O4 2 minus to CO2. That is oxalate to carbon dioxide.
Okay. Then.
H2S2S. That is
Sulfide. Hydrogen sulfide to sulfur.
hydrogen sulfide to sulfur.
Mm.
Mn2 plus to MnO2. That is manganese salt to manganese oxide.
That is Mn plus 2 to Mn plus 4. No. You can put a manganese oxide, but the oxidation state is plus 2 to plus 4.
2 to plus 4.
Okay. Then.
The last one is SO3 2 minus to SO4 2 minus.
That is sulfite to sulfate. So these are all the various. Now you can select at a random. You have got already the center one duly balanced. Okay. So can you do this exercise? For example, you can take anything as you like. Can you take iodine? That is simple.
Okay, sir.
Take iodine, the first one, and complete the half cell.
Should I directly write this and
You can write down at the bottom. I minus. No. You can write. You balance that I minus I2.
okay, sir. I minus 2 I2.
Hmm.
That is 2I minus 2 I2 plus 2 electrons.
Okay. So now you can combine these two. And that is 6. This is 2. So multiply by 3.
That is
6i.
6I is equal to 3I2 plus 6 electrons.
Okay. Now put a vertical line and combine these two equations. Now you have got the redox reaction. It's called something like a potato technique in any 5-star hotels. They have got already half-baked items of all these things, and immediately they can serve any type of food the customer demands. Okay, so likewise, these sketch notes are very, very useful for us to have the overview and do it immediately as we like. Any problem can be solved using this. Okay, now you can combine the Cr2O7 and these two reactions. You can explain.
Yes. So this is the balanced oxidation reaction.
Hmm.
So these are the reducing reagents, sir.
Hmm.
So first, iodide.
Using permanganate.
Using permanganate.
Hmm.
So iodide to iodine.
Hmm.
So I minus to I2.
Hmm.
Ferrous to ferric.
Ferric.
Fe2 plus to
Ferrous ion is oxidized to
ferric.
For instance, if I take ferrous chloride, it becomes ferric chloride. Ferrous sulfate,
Ferric.
that's all. Okay. Hmm.
Yes. Now next is SN2 plus to SN4 plus,
Hmm.
which is stannous to stannate.
Hmm.
Stannate. Then nitrate to nitrite to nitrate. NO2 minus to NO3 minus.
Hmm.
Then S2O3 2 minus to SO4 2 minus.
Hmm.
This is thiosulfate
Hmm.
to sulfate.
Okay.
C2O4 2 minus to CO2.
Hmm.
Oxalate to carbon dioxide. H2S sulfide to sulfur. H2S to S. SO3 2 minus to SO4 2 minus. Sulfide to sulfate. Mn2 plus to form MnO2. Manganese salt to MnO2. Manganese oxide.
Okay. So you can take the I2 to I minus to I2, same like what she has done, using KMnO4, right? You can explain this. So you have combined this.
The half cell, balanced half cell reaction,
Hmm.
and directly I have cancelled the 6 electrons,
Hmm.
and I'll just
Hmm.
put all the reactant product from the two half cell reactions and combine directly came to the final equation.
Hmm. Okay. So put it in the box, the balanced equation. So both of you have done a nice job. Very good. Very good. So this is going to be useful for many candidates, right? I take a photo of this one. This alone.
So we are first multiplying this equation made by 5 to balance the electrons, so 2 electrons. So we are multiplying this equation by 2 so that we can get 10 electrons. We can cancel these 10 electrons, 10 electrons. Then we need to combine it. So 2Mn O4 minus plus 16H plus 10I to form 2Mn2 plus 8H2 plus 5I. This is the last
Very good.
equation.
Very good. That's it. Now let me give you one challenge to both of you. Come. Instead of using the ion, you have to use the salt.
Okay.
Yeah, you can do the same with KMnO4. Can you try?
Yes.
Without ion. Okay? Take the photo. Wait a minute. Wait a minute. You take both together. Yeah, you can erase it completely. Now the challenge is without ion, using the neutral molecule. For example, instead of using Cr2O7 2 minus, you can use K2Cr2O7. Similarly, instead of using MnO4 minus, you are going to use KMnO4.
So we'll both use same reducing.
Reducing, you can use same reducing agent. Take you take anything as you like.
We'll take iodine.
Iodine, huh? That is the simplest one. Okay. So K2Cr2O7,
So
yourself
we follow that
KMnO4.
template.
You can write down first KMnO4, and what is the
I
salt you are going to use? KMnO4
Plus
here
iodine.
K2Cr2O7 plus I.
minus.
I minus means a Ki you can put. You can put Ki, potassium iodide.
Same salt only we should take for the reducing
Ah.
agent.
Otherwise, you take ferrous ferric. That is very easy for you. Take ferrous sulfate, FeSO4, and you have to use appropriate. Put some acid. Put acid. Which acid?
H2SO4.
H2SO4. Okay. Right. Now, what will be the tentative compounds?
Uh,
K2SO4. Here, MnSO4, and in this case, Cr2SO4 thrice because Cr3 plus. Do you understand, Emily?
Yes, sir.
Cr2SO4 thrice. Why? Because Cr3 plus, right? Thrice. Put thrice. Put thrice for sulfate. Sulfate alone. SO4 three times. Right. And then H2O. Then what else? Ferric sulfate, is it not? Fe,
SO4 rice.
Fe2SO4 thrice. Okay? Because ferrous sulfate becomes
Ferric
ferric
sulfate.
sulfate. Okay? And you are supposed to do this by oxidation number method. Right? You have to do all the three. and you can do by algebraic method.
But we should follow the half cell method.
You have to follow half cell only.
Sir, we have to follow.
Oxidation number method. Shrushadika, can you try algebraic method? Both of you can do. Try. You can work out and show it to me. Over.
We'll show it to you, sir.
Then you have to person.
Sir, the first half, sir.
KMnO4, KTSO4, right. MnSO4.
So here this side,
First, then
FeSO4.
SeFSO4 becomes FeTSO4 thrice. That's all. Very good.
Sir, is it correct?
Correct. Fe2SO4 thrice, is it not? Hmm. Use duster. Why you spoil your hands? Why H2O first to solve the sulfate? Where is it? You have solved the potassium and chromium, then sulfate should be balanced, is it not? So balance the sulfate by adding suitable number of sulfuric acid. Okay?
Sir, I should add 4.
K2Cr2 also. See, K2Cr2O7. K2Cr2, right? 2 potassium, 2 potassium. Done. Now sulfate. How many sulfates?
There is 4.
You can compensate by adding 4 sulfuric acid. Is it not? Right.
So how to balance the electrons?
Hmm? Here, you explain this.
2 KMnO4, 2 KMnO4 plus K2SO4 plus MnSO4. So here in the product side, we are having 2 K. We are multiplying it by 2. So Mn becomes 2. So we are multiplying MnSO4 by 2. So we are having 3 SO4 on the product side. So we are adding 3 H2SO4. To balance SO4, we need to add H2SO4 on the deficient side. To form this, so we need to add hydrogen. So we are adding 6H plus.
Okay. Now this side is 0. This is plus. So you want to add x on, x on this side. That's all.
0 plus
0
H.
plus x is equal to 6.
So we need to add 6.
That's all. 6 electrons.
So the next step, can I
Okay,
balance
one
the
of those
oxygen?
recommended. Have you completed oxygen? You are not completed oxygen. Very good.
Sir,
First you have to target this oxygen.
No, so we're taking it as whole.
No. This is sulfate. But what about this? What is that?
Next step, the balance the
See,
oxygen.
this is sulfate. Sulfate is over, is it not?
Yes.
4 sulfate, 4 sulfate. And you are left with oxygen.
Oxygen. I should-
That should be compensated by adding.
Water.
Yes. And similarly, this 4 oxygen should be compensated by adding
8H2. So,
water molecules. Yes.
8H2.
Time. Forty-six minutes, sir. Complete that book. Chapter book. Right?
So, because A16H,
8H2.
so already here 6H. So we are adding 10H. Electrons, 6 electrons.
6 electron. 6 electron or 10 electron?
10 electrons. 10 plus X equals to
0.
0.
Means 10
10
electron.
electrons.
Huh? Huh? Ah. Is it less? Yeah, if you so for the sulfate, first now the sulfur ion. If you SO4 2 minus, Fe2 plus. Done. Again, you can use sulfuric acid. So in the case of Hobson reaction involving, listen, in the case of Hobson reaction involving acids completely, like sulfuric acid, hydrochloric acid, you can make use of the relevant acid itself for balancing the relevant anion. For example, sulfate can be compensated by adding sulfuric acid itself because that acid is available. If it is a hydrochloric acid, chloride means you can use chlorine, hydrochloric acid.
So I have balance.
Explain.
Sure, 4H, H2SO4 plus K2Cr2O7 gives K2SO4 plus Cr2SO4 thrice, sir. To balance the oxygen, here there is 16 oxygen, sir.
You should not count because it is already compensated with sulfate. Finish that. Don't get confused with the sulfate. You're already done with sulfate. Why should you unnecessarily disturb the sulfate? Do you understand? You have to add the water molecule only for compensating oxygen. Okay, erase everything. You understand? You are already done with sulfate, is it not? Then why should you worry about that? Go ahead with K2C at, O7 only. So all other, see, 4 sulfate and here 4 sulfate finished as sulfate finished. Then why should you disturb that oxygen? You have to worry about only the oxygen of K2Cr2O7, and that can be compensated by water molecule. Yeah. You got it? Now you have to
Hydrogen.
hydrogen. How many hydrogen?
Here
14
I have to
hydrogen.
consider this hydrogen.
Yes, that hydrogen should be considered.
So we need to add these both sulfuric acid.
Yes.
3H2SO4 plus 5H2.
You can add.
8H2.
Hmm.
Yes, sir. Next, I have to balance the electron.
You check 4H2SO4, 6H plus over a, right, proceed with ferrous sulfate. And how about the electrons?
Yes.
So fine.
Charges should be compensated. Done?
The complete.
Completed.
Checked by ER.
No. First you explain everything. And you explain from that part, that is K2 KMNO4, you have added H plus. How you added H plus?
Where? 8H.
Here.
Here, right? 10H plus. Yes, sir.
Here. From here.
2 KMNO4 plus 3H2SO4. We are adding 10H plus because sir, I'll explain from this step. 2 KMNO4
Listen.
2 KMNO4 plus 3H2SO4 to form K2SO4 plus 2 MnSO4 plus water. 8H2O. So we are having to balance oxygen, we are adding 8H2O because we
Now
are
that
having,
is, previously you did some mistake. What is that? So
I
you have
didn't-
done, for example, that is sulfate has already been balanced. And you have to balance the
Balance the
oxygen of KMNO4. So you have to attack that one only. You need not worry about sulfate. And here you have got 4 oxygen.
8.
4 oxygen into 2. So 8 oxygen. So that 8 oxygen should be balanced by adding 8 water molecule on this side.
So
Okay.
that we don't want.
So this is 8 into is to 16.
So 16H plus. So
So in that
already we
case,
are
you-
having 6H plus. So we need to add 10H plus. So 6 plus 10, 16 H plus hydrogen atoms are coming. So then we need to balance the electrons. So to balance the electrons, we need to do it by algebraic method. So here 10 is equal to 10 plus
Plus
x.
x. Plus x.
10 plus x.
No, 10
10
plus
plus
x.
x is equal to
10 plus x is equal to
So always remember, you want to
0.
you want to find out the number of electrons to be added, means on the left side only. So take x as the number of electrons. So x is equal to minus
Minus
10
10.
means 10 electrons it should be
We
added.
added on this
Right.
side. So 10 electrons.
Okay.
So
Here.
this side. So in the product side, we are having 2 iron. So we are multiplying this by 2. We need we are having 3 sulfate
Okay.
ions. So we need to add to compensate sulfate. We are adding H2SO4 on the deficient side. So we need to balance the hydrogen. So we are adding 2H plus ions. So by algebraic method, we are finding the electrons.
So, yeah.
0. 0 equals to 2 plus x, which is x is equal to minus 2. So we are
So
to
2 electrons are added in this side.
To balance the electrons, we are multiplying this equation by 5. So we will get 10 electrons.
So our objective is to eliminate this electrons.
So we are cancelling this 10 electron and this 10 electron, and H plus will go also cancelling. So we are
So
combining.
finally, you are able to calculate. Very good. And now you established by your
ERP.
So leave this and yes, yeah, you proceed.
So the next step is we need to balance the electrons.
So
here
here 7H2O. Here 7 2s are 14.
14.
And
Here already we have 8
8,
so I add
6
6 more.
H plus. Okay. Then
Then to balance the electrons, there is 6 electrons.
should be added.
Yes. That is 6 plus 6 is equal to 0. Then 4H2 is 4 plus 3.
Good.
So here we need to balance the iron first. So FeSO4 is equal to Fe2
So
SO4 dries. So we need one more SO2. So we need to add SO4 plus H2SO4 gives.
So should I take the whole sulfate or?
No. Separately. Sulfur separate, oxygen separate.
There's no Fe on the reactor.
Huh?
There's no Fe on the reactor.
You are not written.
Plus Fe.
FeSO4. 10 FeSO4. La. You have missed that. When you combine these two, you have missed it. Nobody has noted.
Sir, 10 minutes, 8 times, sir. Sir,
Write down 10 Fe. 10 FeSO4.
sir,
Hmm.
So let's cancel this right away.
You explain that one, FeSO4.
So I added two Fe to balance this. So next step I have to balance this SO4 twice. So I have just added one more H2SO4. To balance this hydrogen, I have added in the next step
2H plus,
2H
okay.
plus. And in the next step I have to balance
2E.
the electrons, that is 2E. And the final step I have multiplied it by 3 to balance this 6 electrons. So we will get these 2 electrons will get cancelled.
Now you can combine these two. Right.
Yes.
Right at the bottommost. Here, start from here. Yeah. So 4 you have got here, you can add comfortably 4 H2SO4, 3 H2SO4. Always you must write the oxidizing agent first. So start with the K2Cr2, sir. Plus,
H2 is
and here how much? 3.
3.
So 7 H2SO4. Got it?
Yes, sir. Hydrogen here 6 and there also 6. 12H plus.
That is cancelled, no? On opposite side.
Okay, sir.
Cancel it. Oh.
And the next step.
Six Fes, who will put 6 FeSO4? Here. You got 6 FeSO4, you must write. Where you are written? No, on the left side, na. That is on the left side, is it not? Okay. She did the same mistake. Ah. She has simply left that FeSO4 after adding H2SO4. What is that? K2Cr2O7
plus
7H2SO4
plus 6FeSO4
Hmm.
gives to K2SO4 plus Cr2SO4 thrice plus 3Fe2
Cr2SO4 thrice.
Cr2SO4 thrice
Then
plus 3Fe2SO4 thrice plus 7H2.
right now, what you are supposed to do?
I
You
have
have to
ELP.
check by ear. Leave the balanced reaction. So you got everything okay?
Yes, sir.
Get me your book, electrochemistry.
So I completed the ERP.
ERP. Explain.
So first we need to list out all the elements: potassium, manganese, iron, sulfur, hydrogen, and oxygen.
Okay.
So in the reactant part there are two potassium. Also in the product part two potassium.
Okay.
2 Mn. Here also 2 Mn.
Okay.
Then 10 Fe. Here also 10 Fe. Right, these are 10 Fe. Then coming to sulfur, so 8 fours are uh, 8 fours are first 8 plus 8 plus 10. Yeah, 10 into 1 only. So outcomes you need to multiply. So you get 18. So same here also. 3 plus 15 is 18. For the hydrogen part, 8 into 2, 16. Same like here, 8 into 2, 16.
Right.
Coming to the oxygen part, 4 twos are 8. Then 8 fours are 32.
Okay.
Plus 10 into 4, 40.
Okay.
Then 4 plus 8 plus 12 into, like we need to multiply like 4 into 3 into 5. So 4 threes are 12. 12 into 5 is 60. 60 plus 8, 68 plus
80.
will get 80. All this.
Very
Then
good.
charges will get 0.
Okay.
0 charge on both.
Very good. So now we are capable of solving the ionic equation as well as the neutral molecules also. Okay, equations involving neutral molecules. Okay, the same strategy should be followed. Only thing is you must take care of the acid present in that, and if it is SO4, use H2SO4. If it is a Cl, use a HCl. If it is nitrate, use a nitric acid. So likewise you have to do. Okay, very good. So you can erase that part.
Which part?
That fully, completely. Now I will teach you that is how to arrive at the electrochemical equation. Okay. So the same set of equations can be effectively utilized in electrochemical equation, establishing electrochemical equation. Now let me consider, take down yourself, Priya. Yeah, you have finished?
No, sir.
Okay, you carry on. Copper electrode, Cu, put Cu. Yes. No. Cu, solid. Put it in the bracket at the subscript. Solid. slash Cu2 plus aqueous AQ double slash AG plus slash AG within bracket yes. Okay. Guru, can you explain that electrochemical reaction? Come, I'll teach you. You have finished? 2, 2, 2, 13, 13. Okay, done. Very good. You can draw this diagram. 1 minute. Come here. Draw this diagram. You can write. Okay. Draw this diagram. Erase completely.
This
Now,
side or-
this side only. Now listen. See, based on this Hofstall reaction, so we can arrive at the combined reaction that represents the electrochemical equation also. For example, here you can have copper. So on the left side, it is anode. Okay, take down, put anode on the left side. No, at the top. Put anode. No, not extreme. Copper is the anode. Put A, simply A, anode, round it. So always you represent the anode on the left side and cathode on the right side. C on the right side. Extreme right. Extreme right. C. Now this slash represents the cell, that is Cu plus Cu bar Cu2 plus means copper electrode dipped in copper sulfate solution. Instead of copper sulfate, we have simply put Cu2 plus. Right? Okay. So this is the electrode representation. So that represents the anode. Do you understand? And the double slash, that is called salt bridge. That is known as salt bridge. Actually, there is Emily is drawing another cell. Based on that, we will be able to explain. Now, at anode, what type of reaction takes place? Oxidation. At cathode, reduction. Okay. So Ag plus this double slash represents the salt bridge. And again, you have to reverse it. That is Ag plus slash Ag means that is the cathode. That is negative electrode. Ag, silver dipped in silver halide, so silver nitrate solution. Okay, silver nitrate solution. Now listen to me. These two are kept in two different compartments and they are connected through salt bridge. So this is the very idea. Okay. Now listen to me. Here, at anode, write down. At anode, what reaction takes place? You can split this into two. Put no. Leave. Divide equally. At anode, oxidation occurs. Is it not? No, here itself. At anode, oxidation occurs. At cathode, at the top, you can write reduction occurs. At cathode, reduction occurs. What do you mean by oxidation? De-electronation, removal of electron. Now let us consider copper gives copper 2 plus, write down Cu gives Cu2 plus 2E, right? So is it oxidation or reduction? Oxidation. Why? Because the removal of electron, loss of electron is oxidation. Okay. Now listen. So this is the half cell. Okay, it is already balanced. Are you able to follow? And here, Ag, write down. Ag gives Ag plus, Ag plus E. Ag plus E gives Ag. So this is reduction. This is reduction. Now, how many electrons should be added here? 2 electrons. So multiply by 2 into 2. Write down once again. Ag, 2Ag plus 2E gives 2Ag. Now you can combine these two equations. Combine. Put a line. Achcha, the line. So Cu. What are you writing? First start with Cu, man. You can combine straight away. Cu plus left hand side should be added first. Cu and then 2Ag plus. 2E can be cancelled. Gives Cu2 plus 2Ag. So this is called the combined reaction. That one is anodic reaction. On the right hand side, you have got the cathodic reaction. By combining these two, you are able to get electrochemical reaction, right? What is that? Electrochemical. Write down. Put a line. This is electrochemical reaction. Now we want to find out the equilibrium constant for this. What is equilibrium constant?
K.
K is represented as what? It is the ratio between product of the
Divided by reaction.
active mass of the products divided by product of the active mass of the reactants. Here active mass is concentration. So in that case, put K is equal to, no, here, capital K, equilibrium constant. Okay. Capital K is equal to, write down Cu2 plus concentration, box, square bracket into, write down, you know, Ag whole squared, is it not? You have to apply the law of active mass. Ag whole squared, whole divided by Cu product reactant side, bracket left side reactant, Cu, close the bracket, and then Ag plus whole squared. Whole squared. Whole squared. Ag plus, அதுக்கு Ag plus whole squared, அதுக்கு மட்டும். இப்போ, that is for silver, you know, this silver, this is active, the active mass of silver is 1 because solid, take down. Ag, active mass is 1. Ag put bracket, no, that is understood, is equal to 1, put 1. That is equal to 1. That is taken as unity, you can say. 1, okay? So similarly for Cu also it is 1, write down. Is equal to 1. Now replace this, therefore K is equal to what? Cu2 plus concentration divided by, substitute panna, what will you get? Cu2 plus will be there, no? Put Cu2 plus. Put bracket. And then divided by Ag plus square. Is it clear? So this is the equilibrium constant for this product. Okay. And can you write down the cell EMF equation, Nernst equation for this? Write down E cell is equal to, write down E cell is equal to E0 cell minus RT by NF. So can you write comfortably somewhere? You can write here. No, that will mislead. You can erase the top and do it. E cell is equal to E0 cell minus RT by NF into log of natural log of you can put this Ce2 plus K value. This is the Nernst equation or cell EMF for this reaction, electrode reaction. So we can establish the electrochemical reaction with the help of this equation that is called Nernst equation. Are you able to follow? This is known as Nernst equation. And so actually log K, it comes log K. Instead of K, you can substitute here. Okay. So can you write similarly for this equation? Establish the electrode chemical equation for this. You can erase everything. So use this cell and proceed. On the left hand side, you have got put cathode. No, you erase everything. Right. Now, listen here. Go to the diagram. The zinc is, now you have got two compartments. Now listen, you have got two compartments. It's an electrochemical cell. You have two compartments. Left compartment is zinc electrode dipped in zinc sulfate. Write down zinc sulfate in the electrolyte. Similarly, copper electrode dipped in copper sulfate. Okay. Copper sulfate solution as solution, aqueous form. You can write down the formula simply CuSO4 aqueous. Similarly, here ZnSO4 aqueous. Now listen, in this case, that is, you have got the zinc compartment, zinc dipped in zinc sulfate. Listen here, zinc rod dipped in zinc sulfate. On the other side, copper rod dipped in. Can you represent this by cell? Do. ZnSO4, right on, ZnSO4. Put aqueous, ZnSO4 aqueous solution. Okay, so this is the electrochemical cell representation. Do you understand this? So we can represent this entire schematic diagram by this simple equation. What is that? Zinc rod dipped in zinc sulfate. And this can be given in terms of ions also. Can you represent like that? Zn bar, Zn2 plus. It is understood. Put AQ. It means aqueous solution of zinc sulfate. Similarly, copper. Now you have to reverse it, man. This is the way to write. Copper sulfate should be written here. Copper sulfate first, followed by copper. No, that one. The electrode should be at the extreme end. Don't you know? சுத்தமா மறந்து போயிட்ட நீனு. Zinc sulfate போட்டல்ல double slash. Then what about electrolyte should be there. CuSO4 should be there. Okay, right, proceed. Cu2 plus bar Cu. So this is the way we are writing. What is the electrode on the left side? Anode or cathode? Left is always anode. Write down. A. Here at the top only. I never recommend anywhere. C. At anode, what happens? Write down at anode and put at cathode on both sides. Reduction occurs. Now write down Zn becomes what? Zn2 plus 2E, and here write down. You have to proceed. You know the method. Why K? First combine these two equations. Finished? Zn gives Cu2 plus Zn2 plus. Okay, so put it within two lines. Right, now listen to me. And what is the reduction potential for Zn? It is given in this table. That is standard electrode potential. Okay, so that is Zn becomes Zn2 plus. Zinc, where is zinc?
So before 2H2.
Copper,
This is the last
zinc
time
here. Zn2 plus becomes Zn, okay? And its oxidation, reduction potential is 0.76. Write down. Write down the reduction potential near the reduction. You can write here E, put E. We used to write like this, is it not? This is the reduction. That is E Zn 2 plus bar Zn. So this is reduction potential. Slash Zn. The value is minus 0.76. 0 minus 0.76. Okay? Minus 0.76. Now note down this value. This is called reduction potential at standard state. Okay? Then what about copper? You got here copper 2 plus. Write down. Copper 2 plus, that is 0.34. Put volt.
V.
Right? Now you write down this equation Cu2 plus 2E. கொஞ்சம் லைன்லாம் போட்டு ஐசோலேட் பண்ணிக்கங்க எல்லாம் ஒரே இடத்துல எழுதுனா Cu2 plus 2E gives Cu, for which we are given the reduction potential, right? Okay, then what is the Zn2 plus 2E? Write down Zn plus 2E. What is that? Minus 0.76. Write down. I'm sorry, that is, yeah, that's correct. No, you must write like this one, please. Zn2 plus. This is, we are writing a reduction potential.
So why is the minus?
That is equal to minus 0.76. Minus la clear up. Okay, right. Now she asked one important question. Why minus for this and plus for that? It means actually this is called electrochemical series. Electrochemical series is the arrangement of all these standard electrode potential and that too particularly reduction potential. In India, we adopt reduction potential value. What do you mean by potential? That is, in order to that is this copper 2 plus ion to become copper, the voltage required is minus, I mean 0.76 for copper. Similarly, for zinc, it is minus 0.76. So if it is minus means that is it is opposite to the reduction process. That is, it naturally undergoes oxidation. And that is why I put a zinc on the left side. Do you understand this? Just by looking at the value or by comparing the value, when the reduction potential is lower, listen to me carefully, reduction potential is lower. Now, here, what is the reduction potential of a fluorine here? 2.87 voltage. And what is the reduction potential of silver here? Zero point 0.8. So this is 2.7, this is 0.8. Is it not? So this is very high, this is less. It means the reduction potential comes down. Okay, the reduction potential, put ER. The reduction potential value decreases down the electrochemical series. Do you understand this concept? And when we compare this, so down the group means, for instance, here for hydrogen it is 0. So standard electrode potential for hydrogen. So it's called standard hydrogen electrode, SHE. It is always taken as 0. So above that it is plus, below that it is minus. Do you understand? So when we compare two electrodes, okay, so based on the value, we can judge whether this electrode should be kept as anode or cathode based on the value. For example, zinc electrode here, you just look at this zinc electrode. This zinc electrode, it has a minus reduction potential value. It means it naturally undergoes oxidation. Do you understand? So lower the reduction potential, higher will be the oxidation tendency. Okay, what is that? Lower the reduction potential, higher will be the oxidation tendency. So in that case, this acts as anode instead of cathode. Okay, and that is why I have put this on the left side. Now our reaction is Z10 becomes Z10 2 plus only because it is oxidation. Are you able to understand? So in that case, what should be the value? Z10 becomes, you write down what is the natural tendency, Z10 plus 2E only. But what is the value given here? Zn plus 2 plus 2E is minus 7 means just opposite to that. Okay, so the value becomes plus. So you have to write down the value plus there. Do you understand? Yeah. So plus 0.76, 0.76, write down. E, you write down like this on the right hand side, right here. E is equal to E Zn slash Zn2 plus. So that is oxidation potential. I converted this into oxidation potential. Is it clear? That is equal to 0.76. Is it clear now? Okay, right. And what about the copper? Actually, copper that undergoes reduction only here. You can write as such, 0.34. Copper, no. Copper 2 plus slash copper. So that oxidation potential, and here it is, I am changing the value accordingly, 0.34. Now we have combined these two equations, no? You can combine the value also. Okay, so add this value, 0.76 plus 0.34, how much? Write down 0.76 plus 0.34. How much? It means 1 point. So the cell obtained from this equation will have the EM of 1.1 volt. Okay, do you understand this? So E cell is equal to, write down, E cell, capital E cell is equal to 1.1 volt. Is it clear? And that too at standard state. Okay. Standard state means you put 0 at the top. Power. E power E0 cell. எல்லாமே புதுசாக சொல்லிட்டு இருக்கேன். இவ்வளோ தூரம் படிச்சும் பிரயோஜனம் இல்லாமல் இருக்கு. E0 cell 1.1. Okay. Right? Our volt. Put volt. So with the help of this, we can find out the cell EMF of any equation. I hope now you should be able to understand the application of our half cell methods in electrochemical reaction. Is that clear now? Okay,
So this
you got it?
values will be given in the question.
Yeah, they will give you the value. So based on the value, you should be able to arrive at the what? E cell value also. Is that clear? Okay. And so now we are written the, from this cell, we are able to get the cell EM of 1.1 volt. Okay.